Hi, I am Arunraj. I'm a BTech Mechanical Engineering graduate and I have 5 years of teaching experience in mathematics. See, today we are going to deal with mathematics topic trigonometry. See, in trigonometry, what actually trigonometry means? See, it's have two parts, trigono and metry. Trigono means triangles and metry means measurements. Metry means measurements. Okay, see, uh, it deals with the measurements of triangles. Okay, trigonometry that deals measurements of triangle. What are the measurements? See, A, B, C. That's a side A, B, C. At the same time, it deals with these angles. Okay, capital A, capital B, and capital C. Okay, it deals with the sides and the angles of this triangles. But in the case of trigonometry, we mostly deals with, or we only deals with this right angle triangles. Okay, in the case of right angle triangle, we know one angle. That's 90-degree angle. So we need to focus on other two angles. Okay, other two angle B and C. Okay, see, in this case of trigonometry, we know one angle. We can find the sides of this right angle triangle. Okay, we can find the sides of this right angle triangle. It's a lot of applications. It's a lot of applications. Before moving through this application, we need to know the basics. Okay, so if you want to know the basics, we need to know this trigonometric ratios in detail manner. What actually this trigonometric ratios? See, we can move to one slide number 2. See, in this case, this is a triangle, right angle triangle. This angle is theta. If you consider this angle as theta, this is 90-degree. Okay. If you consider this angle as theta, the side that adjacent to this angle theta, we call it as adjacent side. Okay. And the side opposite to this theta, this is opposite side. The side opposite to this angle theta, we call it as opposite side. And the longest side, that's opposite to 90-degree, that's a hypotenuse. Okay, if you consider a right angle triangle and we take an angle theta here, that's angle B, and the side opposite side that's adjacent to this theta, that is adjacent side, and the side opposite to this theta, that's opposite side, and this longest side that's opposite to 90-degree. That's a right angle triangle. Okay, and trigonometric ratio that deals with the ratios of this right angle triangles. Okay, firstly sine of this theta. Okay, sine function that deals with the ratios of opposite side to hypotenuse. Clear? And the cos function that deals with the ratio of adjacent side to hypotenuse. Clear? And tan theta, that's a ratio of opposite side to adjacent. Okay, so this trigonometric function that deals with the ratios of this sides of this right angle triangle, and we have three functions, and the reciprocal is also there, but we are just firstly deals with these three functions. Clear? And after that we can move through this reciprocals. Okay, right now I am not dealing with this reciprocals of the sine, cos and tan, but I am going to deal with this application of this trigonometry by using this tan, sine and cos functions. Okay? See, in this case, okay, in this case, if we know one angle theta, that's 45 degree. Okay, that's 45 degree. This is the height of this tree. If you consider, if you are looking from this point, okay, we are looking from this point to the top of this tree. Okay, if you know this distance from this foot of this tree to the point we are standing though, that's considered as some length that d is equal to 40 meter. D is equal to 40 meter. Okay, find this height of this tree. Okay, we need to find this height of this tree from looking from this point. If you know this angle as 45 degree, what we will do? So we can use trigonometric function, tan function. Why tan function? See, in sine as well as in cos. See, what actually sine function? Sine function is opposite side to hypotenuse. Here, this is the longest side. That's opposite to 90 degree. But hypotenuse. Start here.
Start.
But hypotenuse is not given. So we can't use sine function. At the same time, cos, that's opposite side to hypotenuse. Here also hypotenuse is there, but in this case hypotenuse is not given. So we need to deal with tan function, because tan function, it's opposite side divided by adjacent. See, in this case we know this adjacent. Adjacent is actually the distance from this foot of this tree to the point we have been looking. Okay, so that's a 40 meter. Okay, if you know tan function, that's tan theta is equal to what? Opposite side to adjacent. What's opposite side? That's the height of this tree, h. We need to find. Okay, at the same time, what actually this? It's 40 meter. We know the value of tan theta. See, if you know the value of tan theta, tan 45, so we need to study these values of these tan, cosine for a particular values. In this case, tan 45, it's given in this question, that's equal to 1. Tan 45, that's equal to 1. So tan 45, the value of tan 45, that's a ratio of h to 40. So what actually tan 45? It's 1. 1 is equal to h by 40 and h is equal to simply 40. That's so clear. You got the idea? So if you know this angle as well as one side, we can find this other all sides of this triangle. This is application. See, if you know, if you want to find the height of this tree, we can simply use trigonometric functions. Not only this height of this tree, but in the case of the height of this building, height of this mountain, everywhere we use trigonometric functions. Okay, see, in the case of tree, it's easy. We can just climb and measure. But in the case of mountain, in the case of big buildings, we need to find this height by using this angle of elevation and this distance from where we have been looking to the foot, from this foot of this point. That's if you know this distance, we can find this height. Okay, we can find this height. So not only this height, if this height is given, once this height is given, we can also find this distance from this foot of this point to this area. Okay, so that's all about this, and I think it's clear. So thank you.